Hello class, we're beginning chapter 3 today. We are on lesson number 1 and we're going to learn about integers, and we'll start reading here on page 110 of our text. The substance boiling in a kettle shown in this photograph is being heated by a block of dry ice. Now that's strange. How can we heat something with ice? Well, let's keep reading. Dry ice is much colder than ordinary ice and usually has a temperature of 78 degrees below zero on a Celsius scale. Now that's even stranger. We're heating something with ice that's colder than normal ice. Which, by the way, 70 degrees below zero on a Celsius scale is like 104 below zero. So you can imagine how cold that is. Now, this is very hot, however, in comparison with the liquid in the kettle. It is liquid nitrogen, and its temperature is 196 degrees below zero. That's Celsius. In Fahrenheit, that would be minus 320 degrees Fahrenheit. So now you can compare. And if you see something that's so cold, like negative 320, obviously it's being heated, or at least the temperature is going up when it's being affected by something that's only, quote unquote, 104 degrees below zero. So you can imagine that there's a comparison here, though for us, that is, everything is cold. Really, anything, let's say, below zero is extremely cold. But remember, we're comparing one to the other. So let's keep reading. These temperatures are shown on the scale at the left. The Swedish astronomer who invented the Celsius scale assigned the number 0 to the temperature at which water freezes. Temperatures warmer than 0 degrees Celsius are positive, and temperatures colder than 0 degrees Celsius are negative. Okay, now let's just take a look. And we see here we have water boiling at 100. We have liquid nitrogen all the way at the bottom, and everything in between. We can convert this, for instance, in Fahrenheit. 0, which is where water freezes for Fahrenheit, is 32 degrees Fahrenheit. The water boiling temperature at 100 is actually 212 degrees Fahrenheit. So I like to make reference to Fahrenheit only because I'm sure that you are more accustomed to using that. And throughout the world, they use Celsius. We never really adopted the metric system other than a 2-liter Coke or Pepsi, for those who drink Pepsi. So we don't really use the metric system in our country as it's used throughout. But nonetheless, we still have a scale which goes up and down, and we're also seeing negative numbers. Liquid nitrogen would boil, okay, at negative 328 degrees, more or less. I did the conversion. So negative, somewhere in that, well, actually, let's just say negative 200, I believe, is negative 328. So anyway, let's just let's take a look here, go back to our text. For example, a person's normal body temperature is plus 37 degrees Celsius. And for us, that would be 98.6 is really, and we get down to the decimal, but let's say somewhere between 98 and 99. And the temperature at which dry ice evaporates is negative 78 degrees Celsius. Although the symbols for plus and minus are used here, they do not mean to add or subtract. Okay, let's repeat that. Although the symbols for plus and minus are used here, they do not mean to add or subtract. Instead, they indicate whether the temperature is above or below 0 on the Celsius scale and are read as positive and negative. And again, this is the Celsius scale. We can create our own scale for whatever we want. We can make 0 a point of reference. The point of reference for the Celsius scale, 0, as we read, is at which water freezes. Okay, so they simply said, let's start the scale at freezing point of water, which everyone understands. It's an absolute, and we'll start there from 0 and work our way up, but we'll also work our way down. Up meaning positive, and down meaning negative. If we forget, reading again our text, if we forget about the temperatures and turn such a scale sideways so that the positive numbers are on the right, we get a scale called a number line. Now I have a number line here on our board, which I drew up. Okay, it's at the top of the page, and we can see that there's the larger numbers are going to the right and the smaller numbers are going to the left. Okay, the numbers shown above the line in this figure are called integers. So that was the topic of our lesson, at least the title, and that's what we're discussing here. We're discussing integers. Okay, so we write our word integers. If you've never heard this word, it's important that you know this word. It's a particular set of numbers, let's just say, because numbers can be, they're an infinite number of numbers, okay, including decimals, fractions. Okay, so let's go on and read. As we read from left to right along the line, the integers get larger. The integer plus 4, for example, is larger than plus 3 because plus 4 is to the right of the plus 3. So we're looking at the position, left or right. Let's go over to ours. We see here that plus 4, which is right here. Now we have an arrow over here indicating these are larger, right? So our larger numbers are moving to the right, and our smaller numbers are moving to the left. Okay, so the term that we're using for integers to determine the difference between integers is larger or smaller. Okay, so let's see. We have a 4 and we have a 3. So positive 4 would be larger than positive 3. The number negative 4, on the other hand, is smaller than negative 3. So now let's go over here. Now that's interesting because you would say, well, isn't 4, we have these two, isn't 4 really a bigger number, a larger number? Well, in integers, as we're looking at these and as we're looking at numbers in general, the larger would actually be negative 3 because it's to the right. So this would be actually larger than negative 4. Okay? And I know that we're used to seeing positive numbers, let's say 0, 1, 2, 3, 4, 5. So we would always think as 4 as being larger than 3. But when we start getting to the negative scale, because the numbers are actually getting smaller, we would say that negative 3 is actually larger than negative 4. Okay? The symbol for is larger or more than is, and we've seen this, okay? I'm sure you've seen that before. Larger or smaller than, which depends on which way we're going to go with that. Now something is larger, so we would say that negative 3, right, is larger than negative 4. Or we had the example above here, 4 is larger than or greater than 3. Okay. Notice how the 4 and the 3 get flip-flopped here, only because, remember we said that negative 3 is actually larger than negative 4. Now when we turn it around, we say that it is smaller or less than, and we can show that as we have the example here. We can turn it the other way around and say negative 4 is less than negative 3, or we can say positive 3 is less than 4. Okay, so the bigger number always goes to this open side, larger. It's pointing to the larger. Now this one obviously would read it larger. We would read this less than because this is pointing to something smaller. So you can kind of try to remember that, the visualization, something smaller. I've heard many examples used in this, but just remember this is going to a smaller point and this is kind of pointing to a larger point. Okay, so let's read on. The integers consist of 3 sets of numbers. Now you remember this, you got to remember this. There are positive integers, okay? So that's our first set. Now we understand where the positive integers are. They're on this side, right? So they're all on this side of the 0. Okay. Now what's our next one? Well, we have the negative. And let me just write that over here. You know, negative, and that's pointing to the negative side, anything on this side of 0. And then what's the third set? Well, 0 itself is actually an integer. Okay, 0, I'm going to write it here, and we know that's right over here. Let me see if I can just point an arrow there, and that's where our 0 is. Okay, now what do we know about 0? 0 itself, which is neither positive nor negative. Let's remember, we either have negative, positive, or 0. We do not say that 0 is either positive or negative. Now, because the positive integers are the same as the counting numbers with which everyone becomes familiar as a child, they are usually written without the positive symbol. So instead of writing positive 3, we would just write 3. Okay? But if we're writing a negative and we're saying negative 3, right? Well, yes, we would actually write negative 3. So that's the difference. So the only thing is that we do not include the positive sign when we're dealing with positive numbers. Okay? Now, although we can't count with negative numbers, they are numbers nonetheless. Many measurements with respect to a reference point, such as distance below sea level or time before a certain event, lend themselves to the use of negative numbers. A good understanding of what negative numbers are and how their presence affect calculations will be essential to our work in algebra. So we will study these properties or their properties in several lessons. So our lessons coming are going to deal with that, but it's important today that we understand that we have positive, we have negative numbers, and they're counting numbers. Okay, so we can go positive and negative, and this is 0 is like a point of reference, and they mentioned that our point of reference in the Celsius scale was the boiling point. We can certainly use 0 as a beginning or an end point to many things. I'm saying the beginning or end, meaning the end of a particular time and the beginning of another. So let's say we put someone's birthday there. Okay, so the day that someone's born is a point 0, then there's 1 day, 2 days, 3 days, 4 days, and we also have the days before. -1 meaning the day before, 2 days before, 3 days before, 4 days before. Okay? We can also, like I said, denote a period of time before something, and it's the end of that period and the beginning of another. So we've seen that as well being used in history and in different times. So our own years, our calendar, we all know that we have BC and AD. Okay, and so our own calendars are written in such a way. So we have, but we don't use negatives in that case. We do use the symbol BC and AD. But again, there's a reference point, and you know, the reference point is obviously the birth of Christ. Okay, so we more or less put it right more or less at a time that we can say is right here, and we move forward. With math, we do use positive and negative numbers, and you're going to see how we can add the two, subtract. It gets a little bit confusing if you're not familiar with the integers. So don't underestimate the knowledge that you are acquiring in the very beginning of this lesson or this chapter. It will be essential, as we read, to understand their effects and calculations. Okay? That's the end of this lesson.